Hey everyone, ready to really get deep learning? I feel like it's one of those buzzwords you hear everywhere these days, but what does it actually mean?
Yeah, it's definitely one of those terms that gets thrown around a lot.
Exactly. So today we're gonna cut through all the hype, really break it down so you get a solid grasp of what deep learning actually is, how it works, and why it matters. I mean, this stuff is powering everything from self-driving cars to, you know, breakthroughs in healthcare. It's pretty wild,
Yeah, it's having a huge impact, and I think a lot of people don't realize how much it's already affecting their lives.
for sure. And it can seem kind of intimidating.
Oh, absolutely. Even for folks who are pretty tech savvy.
Totally. So to keep us grounded, we're going to be using this awesome academic paper from Computers Journal. It came out earlier this year. It's like our guide.
Yeah, a really solid overview of the field, so we're not just speculating.
Exactly. All right, so to kick things off, can we just clear up one thing right away?
Right.
I feel like a lot of people use deep learning and machine learning interchangeably, but they're not the same thing, right?
Yeah, you're right. They are different. Think of it this way. Machine learning is kind of the big umbrella, and deep learning is like this specific, powerful type of machine learning.
Okay, so machine learning is the parent category, and deep learning is like the star child.
Uh-huh. Yeah, you could say that. It's definitely getting a lot of attention these days.
Okay, so then what exactly the high S machine learning, for someone who's totally new to this?
Basically, it's all about computers learning from data without you having to program them with explicit instructions for every single step.
Hmm. Okay. Can you give us an example?
Sure, think about your email spam filter. It learns to identify spam messages by analyzing patterns in tons of emails. And it gets better over time without you having to tell it exactly what to look for.
Ah, okay, I get it. So it's learning from experience, basically, but computer experience.
Precisely. And deep learning takes this idea even further. It uses something called deep neural networks to achieve even more impressive results.
Okay. Deep neural networks. That sounds kind of complicated. What's so special about them?
Well, they're inspired by the way our brains work, but they're not trying to be actual brains.
Right. Right.
Instead, they're these complex mathematical models that are really good at finding intricate patterns, the kind of patterns that humans are good at recognizing, but traditional computers struggle with.
Okay, so it's like giving computers this boost of intuition almost.
Yeah, that's a good way to think about it. And that's why deep learning is so powerful and is being applied to all sorts of things.
Right. And that's exactly what we're going to dive into today.
We're going to look at why everyone's so excited about it, and like you said, how it's already impacting all of our lives in ways you might not even realize.
And hopefully by the end of this deep dive, you'll not only understand what deep learning is, but you'll be able to talk about it with your friends and family, sound super smart,
Yeah.
you know.
Haha. No more blank stares at parties when someone brings up neural networks.
Exactly. All right, so let's actually jump into the nitty-gritty. Can we start by breaking down deep learning a bit more?
Yeah.
What's so special about these deep neural networks that makes deep learning so powerful? What makes them deep?
Well, it's literally about depth. These deep neural networks, they have all these layers, unlike the simpler machine learning models.
Okay.
And each layer processes information and passes it to the next one. So the network can learn these increasingly complex representations of the data. It's like it gets more abstract as it goes deeper.
So it's kind of like those layers allow the deep learning to see the bigger picture instead of just focusing on the little details.
Exactly. And that's where the deep comes from. It's about those layers in the network, how deep it goes.
Okay, more layers, more depth, more understanding.
Yeah.
Got it. But how does this actually translate into real-world advantages? What makes deep learning so much better?
Well, our paper here highlights that it really shines when you have tons and tons of data. Unlike older machine learning methods, which kind of plateau at a certain point, deep learning just keeps getting better the more data you feed it.
Oh, wow. So in this day and age where we have big data everywhere, deep learning is the perfect tool.
Yeah, exactly. It's like, think of a chef who's amazing, but they only have a few ingredients. They can only do so much, right?
Yeah.
But give them a whole pantry full of stuff and watch out. That's what deep learning is like with data.
It's like it has an insatiable appetite for data.
It does. And that kind of leads into another advantage. Deep learning can handle messy, unstructured data, the kind of data that's everywhere in the real world.
Okay. Can you give a specific example? What do you mean by messy data?
So imagine you're trying to analyze customer reviews to figure out what people want, their preferences.
Right.
There's gold in there, but it's a mess. Deep learning can go through all that text, find patterns, and give you insights that would take humans forever.
Oh, that's so cool. So it's like your super-powered research assistant
Hmm.
that could actually make sense of all that craziness.
Yeah. Haha, exactly. And this ability to deal with messy data just opens up a ton of possibilities. Take medical images, for example.
Hmm. Okay.
Lots of subtle variations, super complex. Deep learning can analyze those and potentially spot diseases much earlier and more accurately than before.
That's incredible. It sounds like it's already changing healthcare in a big way.
It really is, and that's just one example. Deep learning is being used for self-driving cars, cybersecurity, even creative fields like art and music.
Wow. The possibilities really do seem endless. And you know what? Speaking of possibilities, our paper here has this amazing figure 7, I think it is, that visually shows just how broad these applications are. It's really mind-blowing to see it all laid out like that.
Yeah, it's like a roadmap to the future. It
Yeah.
shows how deep learning is already transforming things and hints at what's still to come.
It's crazy to think that stuff that used to be science fiction is becoming real because of deep learning.
It is.
So let's dive into some specific examples then. I'm super curious about self-driving cars. How does deep learning actually make those work?
Well, think about driving yourself.
Okay.
You're constantly taking in all this visual information, making decisions super fast based on what you see. Deep learning allows self-driving cars to do that too.
Yeah.
It's how they see and understand what's around them. Pedestrians, traffic signals, all those complicated road conditions.
So it's like deep learning is giving those cars eyes and a brain to process it all.
Pretty much. And it's doing it really well, learning and adapting as it goes.
That's awesome. Our listeners are really into health and wellness. So can we talk a bit more about how deep learning is being used in healthcare?
Oh, definitely. So we touched on medical imaging, but there's a lot more. It can help personalize treatment plans, predict how patients will respond to things, even speed up drug discovery.
Wow.
It's really changing how we approach healthcare, making it more precise and efficient.
That's exciting. Like the potential to help us live healthier, longer lives.
Absolutely. And we can't forget about virtual assistants like Siri or Alexa. Deep learning is a big part of why they're getting so much better at what they do.
Oh, right. I remember when those things could barely understand a simple command, and now you can have almost a full-blown conversation with them. It's wild.
It really is. And it's thanks to deep learning, giving them this deeper understanding of language so they can process information and respond in a way that feels much more natural.
It's amazing how smoothly it's become part of our lives. Smartphones, cars, healthcare. It's kind of everywhere you look.
It really is. And we haven't even talked about cybersecurity, optimizing energy, even creating art with deep learning.
It's crazy. It's starting to make sense why people are calling it a transformative technology. But I got to admit, all this talk about neural networks has me kind of curious. How do those things actually work? I don't want to get too technical, but I'd love to at least have a basic understanding.
Of course. It can seem intimidating, but let's break it down. Our paper here, it has a helpful visual, figure 3, that shows the basic building block of a neural network, the artificial neuron.
Okay.
You can think of it like a tiny artificial brain cell.
Oh, wow. Okay.
It gets these inputs like our brain cells do. But instead of electrical signals, it's working with numerical data. And it assigns weights to those inputs, which basically tells it how important each one is. Then it does some calculations and produces an output based on those weighted inputs.
So it's like a simplified version of how our brains process information.
Exactly. Now imagine connecting a whole bunch of those artificial neurons together. That's what makes the network.
Ah, okay. So you're like building this network of mini brains.
Yeah. And the magic happens when those neurons start talking to each other, passing information around, and adjusting their weights based on what they're learning from the data. That's how the network learns.
So the more data it processes, the more refined those connections get, and the better it gets at whatever task it's doing.
Exactly. It's like practicing anything, right?
Yeah.
The more you do it, the better you get. Same with neural networks.
This is really fascinating. It's amazing how something so complex can be boiled down to those little building blocks. But I'm starting to wonder, are all neural networks kind of created equal? Or are there different types?
They're not all the same. It's kind of like you have all these different tools in a toolbox.
Right.
You wouldn't use a hammer to screw in a light bulb. Each tool has its purpose, right?
Yeah, good.
And our paper actually has this great table, table 3, that lists the most common types of deep learning architectures.
Cool.
It's a good way to understand the different flavors of deep learning,
Right.
what each one is best at.
Okay. I'm ready to add some new tools to my deep learning toolbox. So let's start with those image superstars you mentioned, convolutional neural networks,
Mhm.
CNNs. Why are they so good at recognizing patterns in images?
So think about how our own brains process what we see.
Okay.
We have a specific part called the visual cortex that's really good at recognizing shapes, patterns, objects. CNNs are kind of designed to mimic that.
Hmm.
They have these layers that are like filters scanning the image for certain features, and they build up this understanding of the scene piece by piece.
So it's like they're dissecting the image layer by layer.
Exactly. That's why they're so powerful for things like image recognition, object detection, even facial recognition, like how Facebook can tag you in a photo.
It's crazy how they can pick out those details, sometimes even things we might not notice ourselves.
Right, what about those masters of sequences, recurrent neural networks, RNNs? How do they handle data that unfolds over time, like text or speech?
Think about reading a book. You don't understand each word in isolation, right?
Yeah.
The meaning comes from the sequence, the order of the words.
Right.
RNNs are built to capture that. They have these loops in them that allow information to persist, so it's like they have a memory of what came before.
Ah, so they can remember the context, which is so important for understanding language.
Exactly. That's why they're great for things like translation, speech recognition, even generating text that sounds almost human. Pretty impressive. Okay, our listeners always love hearing about the most cutting-edge tech, so let's talk about those creative ones, the generative adversarial networks, or GANs. What makes them so good at creating realistic data?
Okay, imagine you have two artists, right?
Okay.
One's trying to create forgeries that look just like the real deal, and the other is trying to spot the fakes. That's kind of how GANs work.
Huh.
Two networks playing this back and forth game, constantly pushing each other.
So it's like this competition, one trying to fool the other.
Exactly. And through this competition, they both get better. One gets better at creating realistic stuff, and the other gets better at spotting the fakes.
That's so cool. And that explains how GANs are able to make those deep fakes that you see online, right?
Yep. But they're not just about trickery. GANs have a lot of uses, improving image resolution, even creating synthetic data to train other AI models.
Wow, they're like pushing the limits of what's possible with AI.
They really are, and this whole field is constantly evolving. New architectures are being developed all the time.
It's exciting to think about what the future holds for deep learning.
It is, and as it keeps advancing, it's super important for us to understand it, what it can do and what it means for all of us.
Absolutely. Well, I feel like we've covered so much ground today. We started with the basics of machine learning, dove into how these neural networks actually work, and explored all these incredible real-world applications. Self-driving cars, healthcare, even how deep learning is changing creative fields.
And hopefully, our listeners are leaving with a better sense of just how powerful and potentially world-changing this technology is.
Yeah, and I hope they feel like they can actually talk about it now,
Yeah.
not just nod along when someone brings it up.
Haha, exactly. It's not this mysterious thing anymore. It's a fascinating field that's really shaping our world.
Couldn't have said it better myself. Thanks for joining us, everyone, and we'll see you next time for another deep dive into the amazing world of technology and ideas.